Namaste one and all. So today we'll be looking at a concept charge breaking. So what is this? So let us consider a charge Q that breaks into two parts such that when they are separated by a distance small d, the force between them is maximum. Then we need to find how the charge must be broken. So this is what we need to study. So usually we'll be having one question from this. So let us consider there is a charge Q and that is broken into two parts, and the distance between these two parts is given by small letter d. So we need to calculate how much charge is present on first part and how much charge is present on the second part. So let us consider small q is the amount of charge present on the first part. So then obviously the remaining charge is q minus q that is present on the second part. So both of them are separated by a distance of d. With the help of this, we will be able to find the force between these two charges by using Coulomb's law. So that is given by force is equal to K into the first charge Q into second charge Q minus Q divided by the distance between them square, that is d square. Now the next thing is we need to find when the force is maximum. So we need to find when the force is maximum. So the force is maximum uh, has to be found out. So what we can do is we can use the approach of differentiation. So if you look over here, differentiation gives you the slope of the line. So if you look over this graph, force versus q, when is the force maximum? At this point, where the slope is 0, the force is maximum. So with the idea behind this, what we can do is we just need to differentiate this with respect to q, and if you are equating that to 0, it is nothing but we are trying to find the slope, which is 0. So that gives the maximum force. So now the way to find the maximum force is differentiating with respect to q and equating it to 0. So let's consider this equation. So let's reorder this equation. So this turns out to be kq capital letter Q minus kq square divided by d square. Let us take the common terms outside. So that would be k by d square is common. Now let us differentiate this and equate it to 0. So when you differentiate this, so you already know that differential of x to the power of n is n into x to the power of n minus 1. Here you are differentiating q. So that would be q to the power of 1 means 1 into q to the power of 1 minus 1, q to the power of 0 is 1. So that should be 1 into capital Q. So living with q. Here 2 into q to the power of 2 minus 1. So that would be 2 into q. So that is 2q. So the value is k divided by d square, q minus 2q should be equal to 0. So this turns out to be q is equal to 2q, or the other way of expressing is small q is equal to capital Q by 2. So what does this tell you? So here, see, these two are the ways in which the charges should be present on the second and first part. So let us consider the first one. So if the first charge is q, then the second charge capital Q should be equal to what? 2q. So substitute capital Q is equal to 2q. 2q minus q is what? Q. So that would be, so the first charge should be q and the second charge should be also be equal to q. Now let us consider the second option. So if the first charge q is equal to q by 2, then the second charge is substitute small letter q is equal to q by 2. So q minus q by 2 turns out to be q by 2. So that tells you that, so this, if this is q by 2, this has also to be q by 2. I hope you have understood the concept behind this charge breaking problem. So whenever you need to find the maximum force, the simple step is you differentiate that and equate it to 0. Okay, thank you for listening to the concept. I hope you have understood the concept. Thank you for watching the video. I hope you have understood the concept. So to know whether you have understood the concepts better, you need to answer the quiz. The link for the quiz is given in the description below. After answering the quiz, you'll be getting the result. So retake the quiz until you find that you answered all the answers correctly and got the complete out of out results.